Hello viewers, welcome back to my channel MuleSoft-TechZone. So as a part of MuleSoft training for advanced user, this is the fifth topic that I am going to discuss today, and it is all about transaction management. I know that transaction management is quite a vast topic, but I will try to explain in a simpler terms as usual, and I will show you a small demo on how exactly it works. So basically, transaction management in MuleSoft, we have two different types. One is local and one is XA, and we will see what those are. So getting started with what is actually a transaction management. You know, the transactions in Mule application, it is a group of operations. It can be like insert operation, select operation, pushing something, publishing something, or subscribing something, anything, a group of operations that need to either be succeeded together or failed together. So there are two types of transactions. One is local, which is by default we'll be using that. We don't observe that, but by default the transaction type is always local. And the second one is XA transaction. So when I say that need to either succeed together or fail together, for example, you have multiple operations where you need to migrate data from one database to another database and update the status in another database. Like for example, there are three different tables: the source table, the destination table, and one table for updating the status. Imagine that you are picking up the rows from the source table and publishing it into the destination, the target table, and something went wrong during the updating of the status of the table. Okay, in such case, whatever you have inserted, right, it should roll back, because it doesn't make sense. Like when you see the status will always be like, inactive or not, the data is not been transferred, right? But you can still see that the rows have been inserted already. I will show you that in a demo how exactly it works. But either it should succeed together or fail together. That is what transaction management means. And we have two types, as I mentioned here, local and XA transaction. In either of the types, the operation must support the transactions, which means that particular connector must support the transaction management. It is not that every connector has transaction management feature. Okay, for example, you might see like transaction management in database, but you might not be seeing that in Salesforce or any other connector. So whenever you drag and drop the connector, and if you see that there is a field or there is a configuration where we can configure the transaction management, then that particular connector supports the transaction management. So let's get started with the local transaction type. What does like local transaction means, which is actually by default. Okay, so local transaction type refers to a type of transaction that operates with the boundaries of single resource, or for example database, which means like you are operating on a single type of connector. It can be either only database connectors or it can be only VM connectors. It is not the combination of database or something else, database or sales or something like that. Okay, local transaction is all about single resource. So when using a local transaction, this MuleSoft ensures that all the steps or operations within that particular transaction are treated as a single unit, and all operations inside the transaction must belong to the same connector, as I mentioned. For example, if you are using JMS listener or JMS consume, the JMS is a single connector. Okay, you can use multiple operations like JMS listener, JMS consume, like that, or database select, database update, or database delete, but you cannot use more than one single resource or more than one same connector. That is the scope of local transaction type. And if any step fails within the transaction, all the changes made by the previous steps are rolled back and the data is restored to the original state. As I said before, for example, there are two operations. One is an insert operation and delete operation. Suppose you are inserting a new array into a database, and once the insertion is successful, the row from the source table needs to be deleted. For example, something went wrong after inserting the new row into a new table. Okay, the next step was actually like deleting the row. If something went wrong on deleting the row in the source table, then what will happen is whatever the insertion that is happened in the new table, that will roll back. That means that particular row is not been inserted. Okay, because there are two phases. One is like, you know, commit, and there will be two phases that I will be discussing in the coming slides, where commit is the last phase. Okay, once everything is successful, then only the you know, that particular row will be inserted successfully. So basically we are discussing about like transaction management, succeed together or fail together. And the second transaction type is exit transaction type, which differs from the local transaction type. This is across different source. The scope or the feature is same, okay, the functionality is same, but this is across different resources. So basically exit transaction ensures that a group of operations across different resources are treated as a single transaction. When using exit transaction in MuleSoft, you can perform a set of operation that involves multiple resources, such as updating the data in one database and sending a message to a messaging system simultaneously using JMS, anything. Okay, and this XA protocol coordinates the transactional behavior across these resources. So basically it will coordinate between database, between JMS. This particular protocol does that work, ensuring that either all operations again are committed successfully or fails. All the changes made by the previous operations are rolled back. You can see the definitions between local and exit transaction type. They are both same, only that local is more about one single resource or one on or of same connector. But in exit transaction type, we can, if we are dealing with more than one connector or more than one resource, then we have to go with exit transaction type. Now, there are some transactional actions that you can see during the configuration of the connector. Again, as I said, transaction management is only possible if that particular connector supports that. How do you know whether that particular connector supports that or not? It is like if you go to the connector configuration and if you see the transactions configuration, then it means that that particular resource is going to support the transactional management. So transactional actions are nothing but it is the type of action that operations take regarding the transaction. So the first one is like always begin, always join, begin or join if possible, indifferent or none, or not supported. So we have these many transactional types. I will try to explain with one, like in a simple terms, but based upon your use case, you need to choose one of them. Okay, now let's start with always begin. What is always begin? So whenever an operation is set to always begin, it means that a new transaction will always be started regardless of whatever is going on with the previous transaction. So this behavior ensures that the operation is executed in its own isolated transaction and it is not dependent on any other existing transactions. For example, you have like hit one URL to update something in the database. Again, parallelly you are making another call to the same URL. So what it will do is it will always try to create a new transaction which is like not dependent upon the previous transaction. So what is the example? Suppose you have an operation to insert a new customer record into a database. That is your requirement. Okay, you have to insert a new customer. That means that new customer, you can insert multiple customers, right? And whenever you are hitting this new customer endpoint, it should be independent of the other customer. There is no relation between one customer and the another customer. So in such cases, you can use this transaction type as always begin. So even if there is an ongoing transaction for another operations, like for another customer, setting the propagation behavior to always begin, it will start a new transaction specifically for the customer insertion and guaranteeing that it operates independently irrespective of what is happening with another new customer. Okay, in such cases you have to use always begin. So I have tried to give one small example for each transactional types, try to understand in a better way. And second is always join. So this operation is set to always join. It will join an existing transaction if already in one is in progress. If there are no active transactions, what it will do is it will create a new transaction. So just the name itself will say always join. It tells us that if there is already an existing transaction, it will join that particular transaction. If there is no transaction exists, then a new transaction will be created. Example, consider a scenario where you have to update the customer's address and order details in separate database operations. For example, you have your customer address that needs to be stored in one table, and there are some order details which needs to be stored in another table. For example, all e-commerce websites, what they do, right? So what will happen if there is an ongoing transaction for the address update, okay, customer address update, then the order update operation will join the all propagation behavior to that transaction. Okay, if there is no transaction exists, a new one will be started for the order update. For example, so what does it mean? There is parallelly, there are two operations going on. One is like customer address change, okay, and also you are ordering something, right? So what will happen, there is an order, there is a customer change, address change going on. So what order details will do is, order update will do is, it will wait for the customer address change to get completed, because it will join the transaction, and after completion of customer address change, this order update will be created. So it will be, the order will be given to the customer's new address, like that. So if at all there is no customer address change, then what will happen, it will there is only one order update that needs to be done, so it will create a new transaction. We don't have to bother about it. So in such use case, you have to use this always join transaction type. Begin or join. So what does it mean? So this means what it will happen is, it will first check if there is an active transaction going on. Okay, if there is an active transaction, the operation joins that transaction. If there is no transaction in progress, a new transaction is started for the operation. So this is like begin or join. It will see the active transaction. Okay, what is the example? Let's say you have an operation like process payment. You are processing a payment, and there is another operation that needs to send a notification to the customer. Okay, what it will do, if there is no active transaction for the payment processing, the notification operation will, with begin or join, propagation will join the transaction. If there is no transaction exist, it will start a new transaction for the notification, just like more or less the previous one. Okay, and join if possible. With join if possible, this particular operation attempts to join an existing transaction if it is available. If there is no transaction, the operation continues without a transaction. Okay, unless and until there is a transaction, it will join. If there is no transaction going on, then it will not create any kind of transaction. That is all about join if possible. Example, imagine you have an operation that updates a product's stock quantity, like stock, it needs to update the stock quantity. If there is an ongoing transaction for other related operations, the stock update operation with join if possible behavior will join the transaction. If there is no transaction, it will proceed without a transaction. In such scenario, you have to use join if possible. Indifferent. So guys, there are like lot of options here based upon the types. So you need to discuss with your architects, you need to discuss with your stakeholders about what kind of behavior you need, and then choose the transaction type. It's not just like, as we are discussing, like giving one small example and we have to go with it. Okay, so when coming to indifferent transactional type, when it is set to indifferent, it means that it does not enforce any transactional behavior. The operation executes without considering transaction, essentially operating outside of any transactional context. Okay, example, suppose you have an operation that retrieves the list of customers from the database. Since this operation is read only, right, this is a read get operation or select operation. You are not inserting or updating or deleting the existing one, so you are not modifying the data, as it is only the read only thing. So setting this propagation behavior to indifferent mode, it does not require any kind of transactional. You don't have transactional behavior. The reason why we are saying like we have to go with indifferent, for example, in this read only case, transaction management, what it will do is, it will be in a state of CPU intense. Okay, it will be in blocking IO. blocking IO stage. Okay, it will hold the transaction, so it might impact your API performance. But when there is a scenario where you have to use the transactional scope, for example rollback strategies and all, if there is a need, then there is no other option for us than using transactional management. But wherever there is a chance where you don't want to use it, then you can go with this particular indifferent type. None, as the name itself says, that it explicitly states that the operation does not participate in any transactional behavior, and it operates in isolation without even being the part of any ongoing transaction. Example, your loggings, right? To consider an option that logs an event into a database table. Okay, it is like, since logging is typically independent of other transaction, setting the propagation to null indicates that this operation should not be part of any transactional context, because these are just logs. It is not dependent, or this is very important for us, or any other operation is dependent on this. These are just logs, so we don't have to specify any kind of transactional management. And what is not supported, that means it does not support transactional behavior at all. Okay, the operation cannot be executed with a transactional context. Example, suppose you have an operation that performs a database backup, right? Database backup, backing up a database typically requires exclusive access and is not compatible with transactional behavior. So thus setting this to not supported ensures that backup operation is not performed within a transactional context. So this is all about the different types I have seen, but most of you guys will be using always join, or first two transaction types in your real-time projects, though we have discussed all kind of because I try to give an idea about what are different transactional types that we have, and what is the small example that we can relate it to. Now, where can we configure the transaction? That is a big question, right? So first thing is event source. Event source means we have, any flow has like source and process phase, right? So source, for example, listener, HTTP listener, or JMS or VM, etc. All these connectors we can configure in the event source, in those like source area. To initiate a transaction from a Mule event source, we have to configure its transaction type and transactional action. I'll show you that in your in the demo. And where else we can use transaction? Triscope. We have a Triscope where we can configure transaction. You can just open the Triscope's general tab and set the transaction type and transactional action. So every transaction management, we need to do two configurations. One is transactional type, for example whether it is always begin or begin if join, those kind of things. And transactional action means whether it is local or exit transaction. So how transactions affects the scopes means, like for example until successful, try scope, all this stuff. How does it really affect? So when running with a transaction, for example async scope, there is async scope, it will still run in another thread, okay, remaining asynchronous. However, this means that the entire execution of the processes within this async scope is out of the transactional scope. So therefore any error produced inside the async scope does not result in rollback. So whenever you are trying to put transactional management in async scope, please note that it will not roll back. Okay, whenever there is an error occurred, because it is running in an asynchronous mode which will be running in another thread, it will never roll back. So if anyone asks you in the interview questions or anywhere, you can mention that rollback does not happen even though you are trying to put transactional management. What about until successful? So until successful, what it will do, it will block the thread. Okay, it will block the thread, and this means that the thread used by the execution cannot be used to process any other request while until successful scope is performing the delay between the retries. Okay, when there is like you are retrying, right, first attempt, second attempt, it will block the thread. It will not allow any other operation to perform. Okay, and parallel for each. So what it will happen, it does not execute in parallel. If you are setting transactional scope for parallel for each, then this particular parallel for each will not execute in parallel. Okay, this means it executes like a for each scope. So whenever someone asks you a question, how can you make a parallel for each to work like normal for each, then you can say like you can set transactional management in parallel for each so that it will act as a normal for each scope, which means the second element of the collection is processed only after the first one has finished, which is like the normal for each scope. Okay, and this does not affect the way the scope handles the errors. Batch processing. So since batch is also designed to work on parallel just like async scope, and every record is transferred transactionally, again the batch execution is not part of the transaction. Okay, there are different phases, right? Batch, one of them is batch execution, and it is not part of the transaction. So batch processing cannot take the transaction management. Okay, and how come the routers affect? We have choice router, scatter gather router. So how does they affect? So you have to understand in scopes, when it comes to scopes, what kind of scopes. For example, async scope and batch, they do not support transaction management, whereas try scope and until successful they support. So you have to understand in that way, like what kind of connectors are supported by transaction management and what are not supported. Now coming to routers like scatter gather, when running within a transaction, if you are enabling the transaction in a scatter gather connector again does not execute in parallel. Okay, this means that the second router is executed after the first one is processed, and the third one is processed only after successfully processing the second one. And this does not affect the way the component handles the error. Whenever you have a scenario where in scatter gather you want to make multiple calls, multiple updates, okay, you are making one get call and one post call, and in such case you don't want it to run parallelly, but you have to do it like you have to combine the data at a time. So in such case you can use scatter gather and enable the transactional scope so that the scatter gather will not run parallelly. Instead it will go step by step. It will go to the first router. When it is success, then only it will go to the second. When second is successful, then only it will go to the third. So those kind of scenarios you can use this transaction management. How about flow reference? Now if the flow or subflow being executed in running with a transaction. So whenever I am saying like how transactions affect routers, that means I am saying like if you are enabling the transaction, that is the behavior. In the first one scatter gather, I have told like it will execute one after one, right? That means only when you are enabling transaction. If you are not enabling transaction, again it will run parallelly. Okay, so now coming to flow reference, if the flow is running with a transaction, the execution of the flow or a subflow referenced by the flow reference component continues with the same transaction. Okay, if the referenced flow has a mule event source that begins with a transaction, for example, you have listener source, okay, which is set to always begin, then what it will happen? The transactional action is ignored. The flow reference component will execute the referenced flow component except for the event source. Any other router or scope, for example for each, continues with the transaction and its behavior is not modified. This is a bit typical, it's not easy to understand, but when you try out some examples you will try to understand it. Okay, what is this Bitronix? Okay, you might have heard about this. Okay, using Bitronix to manage the transaction. So basically this Bitronix transaction manager, there is a separate, you won't find anything like a connector in your Mule palette, but if you go to the global elements and try to create and search with word Bitronix, you will see that connector. Okay, so this is a transaction manager which allows Mule to automatically recover interrupted transaction on the restart. Okay, whenever there is a restart happens and if there are any interrupted transactions, this Bitronix transaction management will help you to recover them. Okay, for example, if a Mule instance crashed, or when I say Mule instance, application crashed or loses the connectivity to a database or JMS, what will happen? This causes a transaction to fail unexpectedly between the prepare phase and commit phase. I told you, right, there are two phases which we call 2PC. Okay, prepare phase and commit phase. So once prepare phase is done, Prepare phase is like the process where you are trying to do like selection, update, selecting, updating and deleting. Commit phase will only happen once everything is successful, then only the whole process is considered as a success. If there is any error, then commit phase fails and all other things will be rolled back. Okay, and in this case what will happen, the transaction manager needs to run a recovery process to complete any in-flight transaction that was taking place during the failure. So basically Bitronix manager is used, we have to use this in real-time projects, when especially when we are dealing with database connectors and all, because sometimes Mule applications get crashed and we need to recover them. Okay, so what I will try to show you today is a small demo. Okay, before that what I'll do is I'll exit here. I will show my database here. What I'm trying to do is I have bank details. You can see here I have bank details with few rows. I have another table which has new migrated bank details. For now I have only two bank details. Okay, now I want to move the data from bank details to new bank details, and whatever has been done, and this migration status for now I am not going to show anything here, but what I wanted to do is I want to select and insert in the table, and any error occurred in the middle of the table or in the middle of the flow, it should not, whatever is inserted here should be rolled back. Okay, what I have done is, for example, I told you event source. Okay, here if you edit this configuration, give me a second, there is event source where you can configure here. We have database responses. I haven't configured anything here, sorry. So event source, we can have it. If you want to configure, you can configure here. I'm just looking for the transactional scope, but anyways, never bother, we are using database connector. What I'm trying to do is I am enclosing everything within a try block, because try scope, what it will happen is it will box the thread. So you can see here in the try block there are two settings, transactional action and transactional type. For now I want to create a new transaction irrespective of other transaction. Okay, so that's the reason I have used always begin option here. And transactional type I am using local. There is XA option also, but as I am using the same database connector, right, so I don't have to go with XA transaction. I just need local, because I'm dealing with single resource, same connector. Okay, now this configuration is done. Go to database and see how it is being configured. Edit this. If you go to the transaction, I told you, right, if that particular database connector has this transaction configuration, that means it will support the transactions. So I'm just enabling use XA transactions, and here I am not committing anything. Okay, just use this and cancel this. And there is one more thing that I have done here, Bitronix transaction management. If you search here, as I said, if you go back to the design phase, if you search for Bitronix, you won't find anything here. But if you go to global elements, click on create, and you search for Bitronix, you can see Bitronix transaction management. So you can just add it. There is nothing to be configured, you just need to enable that. Okay, so this Bitronix will help in even when you are restarting your application. Now what I will do is, what I'm trying to do is, here this is already in running state. See, go here. So I will keep a debugger breakpoint here and run. Already two IDs were inserted. I am going to select the third one, go here. So I am in here calling for the payload. I have cust ID 3. I got the details. Going next, you can see these are the customer ID 3. I want to insert here. Now after inserting here, you can see I got a success response and the affected rows is 1. However, because we are inside a transactional scope, if you go back into the new migrated table, you can still see there is no third cust ID here. Okay, there are only two rows. Though it shows affected rows as one, usually it has to be, it should have shown like already here in the row. But as the flow is still running, it will think like, there is something, there is another process still which is in process, and if it fails, what it will happen is it will roll back. So now I just completed here, I got a success response, affected rows 1. Now as the flow is completed, if I just refresh, you can see then the row is inserted. So unless and until the whole process completes, it will not read, it will be always in the prepared phase. So once the whole flow completes, it will be in a commit phase. It will commit and the row is inserted here. Now what I will try to do is, I will try to raise an error so that we can see in the error scenario. So raise error, go here, data colon invalid details, invalid bank details. Okay, so now I am configuring, I am trying to raise an error. So here what you can see is, even if the row is, even if it is showing like affected rows 1, when there is an error, it will not insert the columns. So I will start with a new ID. Let me see if my database has these rows. So I'll go with cust ID 8. Okay, let me see if my application is redeployed. Couldn't find the, okay, I'm sorry. So it should be underscore. Okay, let me redeploy this. So next demo, what I will do is, I will remove the try block, I will remove the transaction scope, and you will see the difference between the transaction management when we are enabling, whenever we are enabling the transaction and when we are not enabling the transaction. Let's wait it to be get deployed. Okay, the application is deployed, and also you can see that transaction management, it will say like, this source is started successfully. Okay, now let me send this request. So here, okay, we are getting the data, you can see here, you are getting the details here. Now next step, it is inserted successfully, because if you see, the affected rows is 1. Ideally, after successful completion here, it should include that 4th row. Okay, but as I am raising an error here and completing the flow here, you can see now, though it has shown the affected rows as 1, now if you try to start, run it, you can see the row is not inserted, just because we have enabled transaction management, which means if any of the operations fail, it will roll back whatever is inserted. You saw that affected rows is 1, but it is internally inserted, but as there was an error, it has rolled back. Okay, now I will try to remove and run the same query. Application is restarted. Now I will run this again. Okay, I will execute it, run it, affected rows 1. Now you will be seeing the row here, you can see this row has been inserted. So this is how transaction scope works. Now what I will do is, I will try to remove, I'll go to the XML, I'll try to remove this try block. Okay, which means it is not under any transactional scope, and I will remove this Bitronix transaction, and I will go to the database connector and see if there is any transactions. I will remove everything. Okay, here. So now what I will do is I will add a raise error. Now just wanted to show you that example. Invalid bank underscore details. Invalid details, give it something. Okay, save it, and I will put a breakpoint over here, and I will show you the difference. Meanwhile, I will fetch one new row. I'll take 9, row 9, custody 9. We go and check the console. It is started successfully. Now I will send the request. Now yes, I am getting the details here for custody 9. Okay, now you have to observe one thing. I am inserting, it shows that one row is affected. Okay, and still my process is continuing. However, you can see in the database the row is already inserted here. So that is the difference between applying the transaction management. So irrespective of, for example, now there is an error occurred here. Okay, I am running it, still there is no rollback because we are not using any kind of transaction management. If you run this, you can see the row is already inserted irrespective of the error occurred in your application. So now on the whole, what I wanted to say is, if you have any scenario where one operation is dependent upon the another operation, then you have to go with a transactional management option, so that only if everything is succeeded, everything will be committed properly. If there is any error in the process, it will roll back the previous commits. So this is the scope of transaction management. Hope you have understood this concept. So try to do some POCs, proof of concepts, to understand more. Thank you.